Hi, this is Kantraj KS, Assistant Professor of Physics, Government First Aid College, Malur. This is the class for BSc third semester Physics, Bangalore University North. The title of this paper is Electricity and Magnetism. So let me have the session for 10 transient currents. So we are going to discuss about this concept, self-inductance, definition of self-inductance and explanation, but also the expression for self-inductance and the magnetic field energy stored in inductor. The main learning objectives of this topic is defining or definition of inductance, coefficient of self-inductance, and expression for self-inductance of a coil, and also the energy stored in an inductor. Let me have a topic on self-induction. Before knowing the self-induction concept, we know that a device is called an inductor. Usually, a coil is also called as an inductor. Inductor is a device temporarily stores an energy in the form of magnetic field. So basically, it gives an properties of electromagnet. When a current is flowing through the wire, it's create a magnetic field. So this device is called as an inductor. But whenever the magnetic flux linked with the coil changes and EMF is induced in the same coil, this phenomena is known as self-induction. So that means when a current is established in a closed conducting loop, it produces a magnetic field. This magnetic field has its flux through the area bounded by the loop. The current changes with the time. The flux through the loop changes, hence induced EMF in the loop. This process is called self-induction. Same way, the self-inductance is defined as the property of coil due to which it opposes the change of current flowing through it. So we can have a points like an inductor. The phenomena which I am going to explain is called self-induction, and the property a coil due to which opposes change of current flowing through it, it is called self-inductance. These three things is very important in this topic. So the coil, same coil as phenomena, it opposes the change in current flowing through its self-inductance, and which stores the magnetic field in the form of energy is called as inductor. So in the case of self-inductance, the magnetic field created by changing a current in the circuit itself induces a voltage in the same circuit. Therefore, the voltage is self-induced. So let us explain the concept of self-inductance. So consider a coil connected series with a battery and plug key K, which are shown in the figure. By pressing the key, the current through the coil increases maximum value to the corresponding value. The magnetic flux linked with the coil is also increases. On releasing the key, the current decreases to a zero value and magnetic flux is also decreases. Thus, according to the Lenz's law, the self-induction opposes the growth and decay of current through the circuit when the current is on and off. It is understood that the induced EMF in a coil persists as long as the current in the coil is changing. This concept is known as self-inductance. So it's clearly understood that the induced EMF in the coil persists as long as the current in the coil is changing. If we give the current for the coil, if the coil produces a magnetic field, when the current changes, the magnetic flux is also changing. So once the magnetic flux is changes, the EMF will be induced. So this process, what you can explain, it is called as self-inductance of a coil. Let me see for the next concept. It's called coefficient of self-inductance. When the self-inductance of a coil is said to be 1 Henry, or what is the coefficient of self-inductance, that things we are going to discuss in this concept. When a current flows in a circuit, the magnetic flux produced by the current depends upon the geometry of the circuit. It means when you see any type of a coil, that mainly depending upon the dimensions. The dimension which helps to know about the magnetic field and magnetic flux and the current, everything which explains the concept of the geometric representation, that is called a dimensions. Let pi is the magnetic flux and I is the current flowing that flow in the circuit, then magnetic flux is directly proportional to the current flows through the coil, with the definition of your self-inductance previous concept. So looking back to the same diagram, that pi is proportional to I and pi is equal to Li. L is, by removing the proportionality constant, we just take that L is called as coefficient of self-induction or self-inductance. We can derive an expression for self-inductance of coil from Faraday's law of electromagnetic induction. So when you see the electromagnetic induction topic, the Faraday's will give the explanation about the law. That is, what is that? Whenever there is a change in magnetic flux linked with the coil, the EMF is generated. So this is what is Faraday's law. Faraday's law. Whenever there is a change in magnetic flux linked with the coil, EMF is induced. So E is equal to, that is, when you see about the Faraday's law of induction, E is equal to minus d phi by dt. That is, as the flux is changed, the current is changes, the flux is also changing. Since the flux is changes, that is d phi by dt, the rate of change of flux will induces the EMF in the circuit. The minus sign, it is opposing the current. E is called induced EMF and d phi by dt is rate of change of magnetic flux in Webers per second. Substituting the equation 1 in equation 2. Substitute d phi by dt. Phi is nothing but Li. So substituting Li here, so we get that E is equal to minus L di by dt. The coefficient of self-induction is equal to the induced EMF in the circuit when the rate of current through it is unity. E is equal to minus of L. The SI unit of self-inductance is Henry. The self-inductance of the coil is said to be 1 Henry if 1 volt is induced in it when the current changes at the rate of 1 ampere per second. Di by dt is equal to 1 ampere per second, then E is equal to minus of L. So that means whenever you want to define that E is equal to minus L, see that is from the definition E is equal to L di by dt or L is equal to E divided by di by dt. So if inductance is said to be 1 Henry means if 1 volt is induced in it when the current changes at the rate of 1 ampere per second, then we can define that it is 1 Henry. So let me discuss about another important part, expression for self-inductance of a solenoid. So if you see the solenoid The solenoid means when you have a type of electromagnet. Solenoid is also a type of electromagnet. The purpose which is used to generate a controlled magnetic field through a coil wounded into a flexi, or it is called LX in the form of wound. So this solenoid, you want to calculate the self-inductance of this solenoid. Let us see for this. Consider a solenoid having n number of turns. Let its length be L and area of cross section be A. When a current I is flowing through it, there will be a magnetic field B at a given point of the solenoid. When a current is flowing through the solenoid, there will be a magnetic field around the coil, as we know the definition of the point of your self-inductance. Therefore, the magnetic flux per turn will be equal to B into area of each turn. Pi is always equal to B into A cos theta will get. But when you see the coil, if it is circular, the direction of it's always perpendicular, and the opposing magnetic flux and the field will be always in the same direction. So theta will become 0. So once the theta becomes 0, cos 0 will become 1, so that pi is equal to B into A. However, B is equal to mu naught Ni. This is the magnetic field around the solenoid, which is equal to N is equal to number of turns per unit length. So N divided by L. Substituting the small n value, capital N divided by L. Therefore, the magnetic flux per turn pi is equal to mu naught Ni divided by L into A. Now, the total magnetic flux pi that is connected with the solenoid will given by the product of flux present through every turn, and the total number of turns is pi is equal to mu naught Nia into N by L. So that is, we can write it as mu naught N square Ia divided by L. Let us take it as equation 1. If L is the self-inductance of the coil, so from the concept of self-inductance, when the current changes, or magnetic flux linked with the circuit is directly proportional to the current flowing to the coil, pi is equal to Li, that is equation 2. Combining the equation 1 and 2 from above, we get L is equal to mu naught N square A divided by L. So this is an expression for a self-inductance. Suppose if you have the core, that is, if you have a core that is made up of magnetic materials constant of relative permeability mu r, then L is equal to mu naught mu r N square A divided by L. So this is what is called, which is having the permeability of mu r. If it is air, then we can say that is, it is in a free air. Let us say we can write that L is equal to mu naught N square A divided by L. If a material of having a permeability mu r, then L is equal to mu naught mu r N square A divided by L. This is what is called a self-inductance of a solenoid. Our next concept we are going to discuss about energy stored in an inductor. So whenever if you see the coil, I told inductor is a device which can able to store the magnetic field or magnet in the form of energy. So that is what is the main purpose of device. So how much energy which can store in the inductor? So that I want to calculate by using this concept. So let us consider a circuit consisting of switch, source of EMF E, and the inductor L, and also the resistor R. When circuit is closed, the back EMF opposes the growth in the circuit. The back EMF opposes the growth in the circuit, the current flows against the back EMF and it does the external work. When the current reaches its maximum value, there is no back EMF and no extra work is done by the no extra work the work is done. The total work done is stored as a potential energy. Let E be the induced EMF at a given instant of time t, or E is equal to minus L di by dt. Let dw is the work done in the time interval t and t plus dt, which is given by dw is equal to ei dt. Since how you get this equation means we know potential is equal to work done by charge, or work done is equal to V into Q. The small amount of work done to move the charges, dw is equal to E into dq or V into dq, both are same. We know that I is equal to dq by dt or dq is equal to I into dt. Substituting the value of E in this above equation, minus E di by dt into I into dt, dt get cancels, L di into di. Total work done to increase from 0 to its maximum value, W is equal to integration of dW, integrating the above equation with the limits of 0 to I maximum. Substituting the value of dW here, after integrating, I just with the I di, I square by 2 will get, or W is equal to half times Li square. This is the equation of energy stored in the inductor. So, session understanding. This is understanding the concept of self-inductance and coefficient of self-inductance, showing the equation to calculate the inductance of the coil and calculating the energy stored in the inductor. So these are few multiple choice questions. Let us discuss about this. The property of the coil which a counter EMF is induced in it when the current through the coil is changes is known as we have a definition, it is self-inductance. Which of the following circuit will opposes the change in circuit current? So either capacitance or inductors or resistors, all the above. Which is always opposes takes place, it is called as inductance. Which of the following is not a unit of inductance? Usually when you see about inductance, it is Henry, and also we can say in the definition volt per second per ampere, and coulomb per volt is not the unit of inductance. Which of the following circuit element stores in the electromagnetic field? So it is inductance. Higher the self-inductance of the coil, lesser its Webers per ton. In a small inductance, there will be energy stored and released quickly. So thank you one and all. These are references.